Dear children, welcome to this channel. In this video, we are going to see the examples under the heading properties of inverse trigonometric function. Okay. Example 4.16. Prove that pi by 2 is less than or equal to sin inverse of x plus 2 cos inverse of x is less than or equal to 3 pi by 2. So, in order to prove this inequality, we are going to apply the property. See, by looking at the center part, I can remember the co-function inverse identity, that is sin inverse of x plus cos inverse of x is equal to pi by 2, which is property number 5, which is called co-function inverse identity. So, it remembers that one. Okay. So, we are going to utilize that property. So, we know that sin inverse of x plus cos inverse of x is equal to pi by 2. So, let us utilize this. Okay. So, here sin inverse of x plus 2 cos inverse of x is given. So, what we are going to do? We are going to take the sin inverse of x plus 2 cos inverse of x as sin inverse of x plus cos inverse of x plus cos inverse of x. We are going to split this 2 cos inverse of x as cos inverse of x plus cos inverse of x, because for if you split like this, we can replace this sin inverse of x plus cos inverse of x by pi by 2 by using the co-function inverse identity, that is pi by 2 plus cos inverse of x. Okay. Then after that, how we are going to get this result means, we know that the range of cos inverse of x is the closed interval 0 to pi. Okay. So, range of cos inverse of x is closed interval 0 to pi. This implies that 0 less than or equal to cos inverse of x less than or equal to pi. Cos inverse of x should lies between 0 to pi. Okay. So, let us add pi by 2 throughout, because we need pi by 2 plus cos inverse of x. So, that is why we are adding pi by 2 throughout. So, what happened? Pi by 2 plus 0 is nothing but pi by 2, which is less than or equal to pi by 2 plus cos inverse of x is equal to sin inverse of x plus 2 cos inverse of x. So, we can replace it, and pi by 2 plus pi is 3 pi by 2. So, we have proved the required result, which is the required one. Okay. Hence the proof. Next example 4.17. Simplify cos inverse of cos of 13 pi by 3, tan inverse of tan of 3 pi by 4, secant inverse of secant 5 pi by 3 and sin inverse of sin 10. Okay. So, let us do this one by one. So, to start with, let us do the first one. What is the first problem? Cos inverse of cos of 13 pi by 3. You know that cos inverse of cos theta is equal to theta only if theta belongs to the closed interval 0 to pi. That is the property. But here 13 pi by 3 does not belongs to the closed interval 0 to pi, because as it exceeds 4 pi, this exceeds 4 pi, because we get 13 pi by 3 can be split up as 3 4s are 12 plus pi by 3, that is 4 pi plus pi by 3. So, as it exceeds 4 pi, it does not belongs to the closed interval 0 to pi, right. Therefore, what you have to do, you are going to express this as a sum of a smaller angle plus a 2 pi, 4 pi or whatever it is. So, you have to express it as a sum of multiples of pi plus another smaller angle which belongs to the closed interval 0 to pi. Okay. So, here you can write that range of cos inverse of x is 0 to pi, as this 13 plus pi does not belongs to 0 to pi. Okay. So, we can split this 13 pi by 3 as 3 4s 12. So, 4 pi plus pi by 3, right. And moreover, the cos value of this one and the cos value of this should be equal. So, cos of 13 pi by 3 is equal to cos of 4 pi plus pi by 3. 4 pi means after one rotation 2 pi, 4 pi plus pi by 3 means this lies in the first quadrant. So, what is cos of 4 pi plus pi by 3? Again all ratios are equal. So, it will be equal to cos pi by 3. Now, then this cos pi by 3, where this pi by 3 belongs to the closed interval 0 to pi. Okay. So, 13 pi by 3 is now written as cos pi by 3. So we have to split this 13 pi by 3 as a smaller angle, sum of a smaller angle plus a multiple of pi, and so that their cos values are equal. So after splitting this, we got the smaller angle as pi by 3, which belongs to the first quadrant. Moreover, the cos values are equal. Now we can replace it. Hence, cos inverse of 13 pi by 3 is equal to cos inverse of cos pi by 3, and now pi by 3 belongs to 0 to pi, and by the property it is equal to pi by 3. Now the second one is tan inverse of tan 3 pi by 4. Okay, tan inverse of tan 3 pi by 4. You know that the range of tan inverse is open interval minus pi by 2 to pi by 2. Okay, that means the angle in the fourth quadrant and the first quadrant. But 3 pi by 4 is 45, and 3 into 45 does not belongs to this interval. Okay, therefore we have to find an angle in this interval such a way that the tan values are equal. So you have to replace it. You have to replace by another angle whose tan values are equal, which lies in this interval, right? Now let us take this 3 pi by 4. So try to express this either as a sum or difference of a smaller angle with a multiples of pi. Now you know that 3 pi means 4 pi minus pi by 4, that is 3 pi by 4. So it can be expressed as pi minus pi by 4. So tan 3 pi by 4 is equal to tan of pi minus pi by 4. Okay, this is a smaller angle and this is a multiple of pi. So you have to express either it is a sum or difference of a smaller angle which lies in the first quadrant, the required quadrant here. So tan of pi minus pi by 4. So tan pi minus pi by 4 means pi minus pi by 4 means this lies in the second quadrant. Second quadrant, sign is positive, tan is negative. So it will be tan of pi minus tan pi by 4. Now still you have to express it in the angle either in the first or in the fourth quadrant. So minus tan pi by 4 can be again replaced as tan of minus pi by 4 as minus tan theta is equal to tan of minus theta. Now minus pi by 4 clearly belongs to the fourth quadrant, which is in our required range. Okay, so as minus pi by 4 belongs to the required principal domain, minus pi by 2 to closed interval, open interval pi by 2, minus pi by 2 to pi by 2, we have tan inverse of tan 3 pi by 4 is equal to tan inverse of tan, instead of 3 pi by 4 we are going to replace it as minus pi by 4, right? Now we can apply the identity. Therefore tan inverse of tan theta, where theta belongs to the required principal domain, therefore it will be equal to minus pi by 4. Okay. Now third one is secant inverse of secant 5 pi by 3. Now what is the range of secant inverse? The range of secant inverse is closed interval 0 to pi minus the middle value pi by 2. Okay, except this pi by 2. So no need to worry about this, only you have to check whether the angle belongs to the first quadrant as well as the second quadrant. Okay, but 5 pi by 3 means pi by 3 is 60 and 5 into 60 300, that is doesn't lies in the first quadrant as well as the second quadrant. Therefore you have to find an angle in these two quadrants in such a way that the secant values are equal. Okay. Now for that what you have to do, you have to split this 5 pi by 3 as either as a sum or difference of a smaller angle with the multiples of pi. So 5 pi by 3 can be expressed as, you know that 3 2s are 6, 6 minus 1 is 5. So it can be expressed as 2 pi minus pi by 3. Okay, 2 pi minus pi by 3. Therefore, secant of 5 pi by 3 is equal to secant of 2 pi minus pi by 3. So 2 pi minus pi by 3 means where it lies? Here 2 pi minus pi by 3 means it lies in the fourth quadrant. In the fourth quadrant, cos is positive and hence secant is also positive. That is equal to secant pi by 3. Okay. Now pi by 3 belongs to, clearly pi by 3 belongs to 0 pi minus this pi by 2. Okay, the required principal domain, that required range. Okay, so this pi by 3 belongs to that one, and therefore we can find out the final answer as secant inverse of secant 5 pi by 3 is equal to secant inverse of secant pi by 3, which is equal to pi by 3. Now fourth subdivision is sine inverse of sine 10. Okay. You know that the range of sine inverse is closed interval minus pi by 2 to plus pi by 2. Okay. The range of sine inverse is closed interval minus pi by 2 to pi by 2. Then here 10 is not a numerical value. It is neither a degree nor a radians nor in radians. So in order to how to check whether it belongs to this closed interval means instead of taking pi as 180 degree or radians in radians, you have to take the numerical value of pi, which is 22 by 7 or approximately 3.14. Okay. So what would be this closed interval in the numerical value by replacing pi as 3.14 means it would be equal to minus 1.57 to plus 1.57, taking pi as 3.14. Okay, taking pi as 3.14, this will be minus 1.57 to 1.57. So 10 doesn't belongs to this interval. So we cannot apply the identity as sine inverse of sine theta is equal to theta. So sine inverse of sine 10 will not be equal to 10 as 10 does not belongs to this interval. Okay, so 10 does not belongs to minus pi by 2 to pi by 2. So what is the rule? Means if it is doesn't belongs to the required range means what we will do? We will find out an approximate value in this another angle in this interval such that their sine values will be equal. So you have to find a number in this interval in such a way that the sine values are equal. Okay. So in the previous problem what we did, we express it as a sum of n pi plus another smaller angle, but our sum or difference of n pi plus a smaller angle. But here 10 is a bigger one because we have to find out a smaller value than 10. So what you are going to do, let us subtract pi or 2 pi, 3 pi from 10 and then find out a suitable value which belongs to this interval. Okay. So let us check whether which one belongs to the smaller value belongs to this interval. So when we subtract pi from 10, that is 10 minus pi, that is what is pi? Pi is 3.14, 10 minus 3.14 will be 6.86. Still it is doesn't belongs to this interval. So again let us reduce still. So let us reduce 2 pi from 10. So 10 minus 2 into 3.14 will be 6.28. So on subtraction it will be 3.72. Again it doesn't belongs to this interval. So again let us subtract one more pi, that is 10 minus 3 pi. So 3 pi will be 9.42. So it will be equal to 0.58. 0.58 is a smaller value belongs to this interval. Okay. So we have found out 10 minus 3 pi belongs to this interval, but we have to check whether sine of 10 minus 3 pi and sine 10 will be equal. Then only we can replace 10 as 10 minus 3 pi and we have to use the identity. Okay. So let us check whether their sine values are equal. Now let us take this as sine 10. So what we are going to do, let us add one 3 pi and subtract one 3 pi. Okay. Without loss of generality, we are going to add one 3 pi and subtract 3 pi. And then this 3 pi can be expressed as 2 pi plus 10 minus 3 pi. Okay. So let us split this 3 pi as 2 pi plus 10 minus 3 pi. Now sine of 2 pi means here this is pi 2 pi. 2 pi plus means it lies in the first quadrant. First quadrant all ratios are positive, so sine is also positive. So we can replace it as sine of pi plus 10 minus 3 pi. Okay. Now again apply the rule. Sine of pi plus means pi is here. Sine of pi plus means it lies in the third quadrant. Here sine is negative. So it will be equal to minus sine of 10 minus 3 pi. So in order to get rid of this minus, let us involve this minus inside. So what happened? Minus sine theta will be equal to sine of minus theta. So when absorbing this minus inside, you have sine of 3 pi minus 10. Okay. Sine of 3 pi minus 10. But here we have found out 10 minus 3 pi is equal to 0.58, but we got that sine 10 is equal to sine of 3 pi minus 10. So what is 10 minus 3 pi? 0.58 means what is 3 pi minus 10? 3 pi minus 10 will be minus 0.58. Again it belongs to which interval? The closed interval minus pi by 2 to pi by 2. That is minus that is nothing but minus 1.57 to plus 1.57. Okay. So we have found out an angle 3 pi minus 10, the value 3 pi minus 10 whose sine values are equal. Okay. So, instead of 10 we can replace it as 3 pi minus 10, and therefore, sine inverse of sine 10 is equal to sine inverse of sine of 3 pi minus 10, and that is equal to 3 pi minus 10. Next example 4.18, find the value of sine of pi by 3 minus sine inverse of minus 1 by 2. Second subdivision cos of 1 by 2 into cos inverse of 1 by 8, and the third subdivision tan of 1 by 2 into sine inverse of 2a by 1 plus a squared plus 1 by 2 into cos inverse of 1 minus a squared by 1 plus a squared. So, here we are all going to use the property. Okay. Now, taking the first problem, let us replace sine inverse, find out what is sine inverse of minus 1 by 2. We have already done this, okay, in other previous exercises. So, let us find its value first, alright. So, sine inverse of minus 1 by 2, let us find out sine inverse of minus 1 by 2. So, you know that how to find the value of sine inverse of minus 1 by 2. The principal value should lie between the minus pi by 2 to plus pi by 2 for sine inverse. That is, you have to find an angle in the fourth quadrant or in the first quadrant. Okay. So, as here it is negative, what is the rule? When it is negative, as it lies in the fourth quadrant, then means the angle y should be equal to minus theta. Okay, y should be equal to minus theta. If it lies in negative, it should be in the fourth quadrant. That means y is equal to minus theta. So, for what value of theta, it will be sine value will be 1 by 2, means it is equal to pi by 6. You know that sine of pi by 6 is equal to 1 by 2. So, as it is negative, the value should lies in the fourth quadrant. That means we have to take y as minus theta, and that is equal to pi by theta minus pi by 6. The principal value must be equal to minus pi by 6. So, sine inverse of minus 1 by 2 is equal to minus pi by 6. Okay. Therefore, sine of pi by 3 minus sine inverse of minus 1 by 2 is now replaced by sine of pi by 3 minus of minus pi by 6. Okay, we have replaced its value as minus pi by 6. That is nothing but sine of pi by 3 plus pi by 6. So, what is pi by 3? 60 degree, pi by 6 is 30 degree. So, 60 plus 30, 90, that is in radians, it is pi by 2. So, sine 90 is 1. So, the value is 1. Okay. Then, second one, what is the second problem? Cos of 1 by 2 into cos inverse of 1 by 8. Okay, cos of 1 by 2 into cos inverse of 1 by 8. So, but the cos here you have to find it the value. In the previous problem, we have sin inverse of 1 by 2, and 1 by 2 is a value of some the specific angle. So, easily we found the value as minus pi by 6. But here 1 by 8 is given, and 1 by 8 is not a cos value of cosine value of any specific angle. So, what you are going to do in that case, you have to take this as to be some theta. So, let us take this cos inverse of 1 by 8 to be some theta, because it does not represent any specific cosine value of any specific angle, that is 30, 60, 90, etc., 45 degree, etc. So, in that case you have to take this to be some theta, and then in turn it cos theta will be equal to 1 by 8. Okay. After substituting cos theta, cos inverse of 1 by 8 as theta, the given problem reduces to cos theta by 2. Okay. If you replace cos inverse of 1 by 8 as theta, what happened to the given problem? The given problem will be reduces to cos theta by 2. It is not equal to cos theta. So, you have to find out cos theta by 2, where cos theta is 1 by 8. So, for that you are going to use the half angle formula. You know that cos 2 theta is equal to 2 cos squared theta minus 1. So, the half angle formula is cos theta will be equal to 2 cos squared theta by 2 minus 1. So, this is the one which relates cos theta and cos theta by 2. So, we have cos theta as 1 by 8 and we need cos theta by 2. So, you are going to use this half angle formula which relates the required one and the given one. Okay. So, that is why we are going to use this formula. So, cos theta is equal to 2 cos squared theta by 2 minus 1. Cos theta is given as 1 by 8 and we need cos theta by 2. So, let it be and minus 1. So, let us find out the value of cos theta by 2 from this expression. So, 2 cos squared theta by 2 is equal to 1 by 8 plus 1, that is equal to 9 by 8, or cos squared theta by 2 is equal to 9 by multiplying this 2 to the denominator it will be 16, or cos theta by 2 is equal to, taking the square root we have 3 by 4, by taking the positive value we have taken 3 by 4, cos theta by 2 was 3 by 4. Okay. Therefore, the given expression is cos of 1 by 2 into cos inverse of 1 by 8 is equal to cos inverse of 1 by 8 is taken as theta, so it will be theta by 2. Now, what we have found out cos theta by 2 as 3 by 4. So, what is the value of the given expression? 3 by 4. Okay, do you understand this? So, as we substitute cos inverse of 1 by 8 as theta, it reduces to theta by 2. So, in order to find the value of cos theta by 2 using this cos theta, we have we have used this relation which relates cos theta and cos theta by 2. Okay. Next, for third subdivision, tan of 1 by 2 into sin inverse of 2a by 1 plus x squared plus 1 by 2 into cos inverse of 1 minus a squared by 1 plus a squared. Okay. Now, look here, the term inside the bracket refers to reminds one formula, that is 2 tan theta by 1 plus tan squared theta. So, if we replace a by tan theta, it will be reduced to 2 tan theta by 1 plus tan squared theta, which is nothing but sin 2 theta. Similarly, here by replacing a by tan theta, we have 1 minus tan squared theta by 1 plus tan squared theta, which is nothing but cos 2 theta. So, easily we can apply the identity. Therefore, what we are going to do? We are going to replace, as it remains the formula, let us replace a by tan theta. Okay. So, put a is equal to tan theta. Therefore, sin inverse of 2a by 1 plus a squared is equal to sin inverse of 2 tan theta divided by 1 plus tan squared theta. So, this is nothing but sin 2 theta. So, sin inverse of sin 2 theta will be is equal to 2 theta. Okay. And then cos inverse of 1 minus a squared by 1 plus a squared is equal to cos inverse of 1 minus tan squared theta divided by 1 plus tan squared theta. This is nothing but cos 2 theta. So, here cos inverse of cos 2 theta is equal to 2 theta. So, remember, when numerical value is given, then only you have to check whether it belongs to the respective range or range. Okay. So, here as variables are used, no need to check, because the problem will be given in such a way that the variables belongs to the respective domain or range. Okay. So, no need to worry about that. Only in the case of numerical value, you have to check whether it belongs to that respective range. So, here it is a variable, no need to worry about the range. Okay. Directly you can apply the identity, that is sin inverse of sin 2 theta will be equal to 2 theta. Now, therefore, this given one, tan of half into sin inverse of 2a by 1 plus a squared plus 1 by 2 into cos inverse of 1 minus a squared by 1 plus a squared is equal to tan of half into, what is this one? 2 theta. So, 2 theta plus half into, this is also equal to 2 theta. So, cancelling this 2 and 2, theta plus theta will be equal to 2 theta, tan 2 theta. Okay. So, what happened to this? This is equal to tan 2 theta. Now, we have taken theta by, this theta is not given in the problem, the variable given in the problem is a, but we have assumed a as tan theta. So, theta is our assumption. So, you have to give, you shouldn't give the answer in theta. So, you have to give the answer only in the given variable a. So, what you have to do? Again, you have to replace this value to tan 2 theta in terms of a. Okay, that is tan theta. So, what is the value of tan 2 theta? Tan 2 theta is equal to 2 tan theta divided by 1 minus tan squared theta. So, replacing tan theta by a, we have 2a divided by 1 minus a squared. So, the given problem has the solution 2a by 1 minus a squared. As theta is our assumption, you shouldn't give the answer in the theta itself. So, you have to give the answer in the given variable a. So, that is why we have changed tan to theta in form of 2a by 1 minus a squared. Okay. Then example 4.19, prove that tan of sin inverse of x is equal to x by root of 1 minus x squared for modulus of x less than 1. See, we did the same problem as example 4.11. As example 4.11. There, we did the problem as in 3 cases by taking x is equal to 0 and by taking 0 less than x less than 1 and minus 1 less than x less than 0. And then the same problem can be done in an easy way by using the property. Okay, let us see how to do the same problem by using the property. Now, let us take this sin inverse of x is equal to some theta. So, this in turn implies sin inverse of x is equal to theta. This in turn implies x is equal to sin theta. Now, as x sin inverse of x is theta means x, the domain of sin inverse of x is minus 1 to 1. Therefore, x belongs to the closed interval minus 1 comma 1. This implies that modulus of x is less than 1. Okay, modulus of x is less than 1. Now, tan of sin inverse of x is equal to tan theta by replacing sin inverse of x by theta. Tan theta can be expressed as sin theta by cos theta. Okay, and then sin theta divided by cos theta can be expressed as 1 minus root of 1 minus sin squared theta. Because the range of sin is closed interval minus pi by 2 to pi by 2, and then in both the that means the angle belongs to the first quadrant and fourth quadrant. In that cos is positive, therefore we can replace cos theta by root of 1 minus sin squared theta. Okay, then replacing sin theta by x, we have x divided by root of 1 minus x squared. Therefore, tan of sin inverse of x is equal to x by root of 1 minus x squared provided modulus of x is less than 1. Here x belongs to minus closed interval minus 1 comma 1 implies modulus of x is less than or equal to 1, which in turn we can take modulus of x is less than 1. Okay, the required condition, right? So, therefore, tan of sin inverse of x is equal to x divided by root of 1 minus x squared provided modulus of x is less than 1.